We are back on the main screen. We can also pull down to refresh device and group lists. This prompts the application to start discovering more devices and groups. Network and group actions may span areas beyond the app's detection. If a node or group is missing, refreshing can help. Nodes found during a refresh are highlighted in red in the top left corner. Only nodes found through the latest refresh attempt are highlighted this way. We can identify any node by clicking on the identification icon. The luminaires will be identified by flashing. For example, let's identify node 6421 from our view. The luminaire starts the identification process. I will now proceed with creating the group. I will select nodes 58175, 27595, and 6421, then scroll down to 29149. My scenario, one room with 4 luminaires that I correctly identified. I will create the group by selecting the New Group button. Before we proceed with creating the group, let's review the options available to us when setting it up. We need to determine which floor this group is on, ranging from -32 to 31. We need to assign an ID to the group, ranging from 1 to 254. And finally, we have to choose what area type this group belongs to. We select one option from the list. In my scenario, I'm creating a group on the 5th floor, and this is my first group on that floor, which is associated with the room. Let's now discuss these options to better understand which group types are available. The first option is occupied level. We can select this if we want all nodes in the group to follow the same occupied level. The value can be set later. The second option is member light level, which means that if the node in this group is triggered, only that node will be on the occupied level, and the rest will follow the member light level set with the slider. The third option is to set the member light level to 0% and slide the slider to the left to create a logical group. This group will not respond to movement as a group, but it can be used for other purposes, such as setting parameters, corridor hold, and wall panel. I will proceed to create an occupied group so that all nodes turn on simultaneously at the predefined light level. I will tick the option to use the occupied level. The group is created and the selected node will flash. We are now in the Settings tab. This is where we can start adjusting levels and timings for this newly created group. I will click on the Edit button. We can adjust the levels or click the Load button. When clicked, we can load the presets we created. In my case, only the default is available as I haven't made any presets. I won't be using any preset this time, so I will close this window. In the Levels tab, I will adjust the timing for the occupied, power save, and minimum levels by sliding individual sliders. In my example, I chose occupied at 65%, power save at 10%, and minimum at 0%. Let's now adjust the timeout in the Timing tab. I will use my own 5-minute occupancy timeout with a 1-minute transition time, and I will set the fade up to 1 second and the fade down to 4 seconds. This will be my preferred scenario. I will confirm my choice by clicking the tick in the top right corner. The group of luminaires we just created will confirm this action by flashing, and we should see our setting. In the Device tab, we can see the devices that belong to this group. In my scenario, nodes that belong to group 5.1 are displayed. Let's click on the plus button. This allows us to add another node or wireless wall panel. I will close this menu. Let's discuss the Rules tab. The corridor features a function that allows you to set one group to follow another. An example of this is keeping the corridor lights on while people remain in a meeting room. Another example is maintaining the first row of lights next to the window or near an exit on while someone is in the open plan office. You can add one or multiple groups from the Select Groups list. This list displays all nearby groups previously detected by the app, which are also listed on the Main Groups tab. In the corridor hold state, Group members will utilize their power save level when the following group is in an occupied state. If other states are active, such as corridor movement, the nodes will adopt the state that provides the highest lighting level. An example use case for the feature is keeping the corridor lights on while people are still in a meeting room. The member light level is where we can check or adjust our group behavior. And finally, we have the daylight harvesting menu. The purpose of daylight harvesting, DLH, is to reduce the use of artificial light when natural light is available. The light sensor measures the amount of light reflected from the surface directly below it, allowing the luminaire to respond to natural light in the space by dimming, helping save energy while maintaining an optimal lighting level for the user. For DLH to operate correctly, the system requires a target level that corresponds to the light sensor reading when the space is occupied and no daylight is present. The system will attempt to maintain this target level while in the occupied state, dimming the light downwards when daylight is present and increasing it when more light is needed. By default, the target level is automatically measured within a few days of space usage, but you can also take a snapshot of the light sensor reading and use it as the target level. This allows you to choose the conditions under which you want to measure the target level. When taking a snapshot, ensure that no daylight is present. The surface beneath the sensor is the correct one, and that the lux level in the space is what you are aiming for. Set the occupied light output level to the desired level before taking a target level snapshot. If you change the occupied level to automatic, the DLH target is reset and will be recalculated using the automatic algorithm, or a new snapshot should be taken. Minimum and maximum dimming levels are the boundaries within which the light level is maintained during harvesting. Typically, the maximum dimming level is set higher than the occupied light level. If the maximum dimming level is lower than the occupied level, the lights will freely dim up and down until it reaches the maximum dimming level. I will allow this to operate automatically and exit this menu. The three-dot menu in the top right corner offers advanced options. Let's discuss these in the next step. We click for options. Let's start with the first item, rename. We can rename the floor and ID we assigned to the group when creating it, or change them later if modifications are needed. For example, the area type might change later, and we can adjust the group's type accordingly. Reset. This menu allows us to reset certain parameters for the created group nodes. For example, we can reset the learning data or reset all the parameters in the group to the default. Learning. By utilizing sensor data and AI, the system can recognize and remember space use patterns and automatically and continuously adapt lighting to changes in space use over time. That results in predictive lighting, which turns the ActiveAhead lights on before the person moving through the space, offering a sense of comfort and security. A luminaire continuously collects data about its neighboring luminaires. Learning is based on data from its own sensors and those of its neighbors. Learning is enabled by default on the ActiveAhead nodes and can be disabled where necessary. Remove group. This will delete the created group and all nodes within it. This confirmation action is required when this is executed, as it will delete this group. Set ActiveAhead scene. ActiveAhead scenes can be assigned to a node, group, or network. Only one scene can be set at a time. When modifying the scenes of a node, they are queried first. A value can be set for light level and color temperature, or they can be set as ignore by disabling the toggle next to the slider. The walk test will cause the targeted nodes to enter an unoccupied state using the specified fade down time. If movement is detected, the nodes will react immediately and fade up to the occupied light level. Therefore, the walk test requires the space to be empty. No one should move there or disturb your test process. When the test is started, you will receive a confirmation. Live control is a function that provides us with direct control over the selected group of nodes. For example, you can use this when setting up the scene levels. We can control the intensity and color temperature of the group. In our scenario, we are still controlling group 5.1. We can exit this function by pressing Reset to Occupied. Presence detection settings allow you to disable PIR presence detection. Disabling a sensor is only necessary in rare cases, such as when an HVAC system produces heat variation within the sensor's operating range, causing unwanted triggers. The feature is supported on firmware version 1.23 and above. The presence detection settings page allows you to configure various trigger filters and sensor settling time. These options should not be changed unless instructed by Helvar support. This feature maximizes energy savings by turning lights on only when the wall panel is actively used. Sensors are used to keep the lights on while the space is occupied. Absence is detected if no movement is detected within the occupied timeout. When the group is in an off state, detected movement does not trigger the lights to switch on. When absence detection is activated, the group's luminaires immediately change their state and light level to unoccupied. We can enable or disable this function. Please ensure the panel is programmed in that group before enabling this function.